All right, so now let's talk about a little bit more with vectors. We're going to talk about the dot product. So first, let's understand the significance of it. So if we have two vectors and we're multiplying together, that's called the dot product. So this is a little bit different than multiplication. So it's defined as A1 times A2 plus B1 times B2. So notice that we're not getting a vector for our answer. What we're getting is a scalar, which is just a number. So for example, if we had to find the dot product of these two vectors, so if we were looking at vector v and w, the dot product of those two. So that again is going to be taking the horizontal components, multiplying those by each other, and adding the vertical components multiplied together. So I get -6 plus 40, which is 34. If we had to find v times v, so that's going to be 2 times 2. So you take the horizontal component plus 5 times 5, which gives you 4 plus 25, which is 29. So the following properties are proved in the textbook, so we're going to actually focus on them. I'm not going to show the proofs, but if you're interested, you can totally look in the e-text. So first of all, dot product does the commutative property, just like 2 times 3 is the same thing as 3 times 2, so that order doesn't matter. You can also use the distributive property with it, so this is the same thing as vector u dot product to vector v plus u dot product w. And then if you're multiplying a vector by itself twice, as you saw hopefully on the other side, it ends up giving you just a squared, because you're just multiplying this times itself twice, plus b squared, which is the same thing as the magnitude squared, because remember the magnitude is the square root of a squared plus b squared. So then if you square both sides, you'll get, when I square this side, a squared plus b squared, which is kind of cool. And then if you have a scalar with it, or the 0 vector times any other vector, it's always going to be 0. And then here's another really cool thing that you might not know. This is another formula to know. So obviously if we're doing the commutative property or multiplying them together, you multiply the horizontal components plus the multiplication of the vertical components. But another formula for this, and again the proof is in your book if you want to see where this is derived from, is you can take the magnitude of u times the magnitude of v times the cosine of the angle that's in between u and v. So you'll get